Hello friends, welcome to Data Science Lovers. In this video, we will learn how to create 1D array, 2D array, 3D array, and we will also check the dimensions, shape and size of these arrays. So I am not covering the theoretical part in this video, I am covering only practical. So this is the example of array. This is 1D array where I have two elements. This is 2D array where we have two rows and three columns, and this is our 3D array where we have one matrix and three rows and three columns. So this is for your reference purpose only. First of all, we will import the numpy module. Import numpy as np. This is the syntax to import the numpy module. I will run this. The command has been executed. Now first of all, I will create a 1D array, and the syntax to create 1D array is our array name. Here I am giving the name A1 and np dot array and round brackets. In these round brackets, we have to pass the elements for array. We can pass the elements in list or tuple form. Here I will pass the elements in list form. So I will write 1, 2, 3, 4. So these are the four elements that I have passed for this array. Now if I run this, then the command has been executed successfully. Now to have a look at my array, I will use print command or print function, print a1. A1 is my variable where I have created the array. Now if you see here, this is my 1D array with four elements, 1, 2, 3, 4. This is how we can create a 1D array. The syntax will be np our numpy module dot array and the elements in the round brackets. Now if I check the type of a1, you can see it is numpy dot nd array. Nd array is an array object. We can also check the shape of this array, writing the array name a1 or array variable name. You can say a1 dot shape. The shape is 4 here, means there are 4 elements, or you can say 4 columns in this array, and since there are no rows, so it is showing blank after comma. We can also check the size of this array, a1 dot size. This is the syntax, and it is showing 4, means there are 4 elements in this array. So this is how we can create a simple 1D array. Can check the type, shape and size of the arrays. Now we will create a 2D array. Again I will assign a variable name for my 2D array. I am assigning now a2. a2 equal to np dot array. Syntax to create a array. Here I will pass two square brackets because I have to create 2D array, and then I will pass the values 1, 2, 3, 4. This is my first element of this 2D array, and in second I will pass other values 5, 6, 7, 8. So this is how I will create a 2D array, means I have to pass two square brackets here. If you see here, one square bracket, first one is for the whole array and it is closing here, and this square bracket is for this list item, and this square bracket is for this item. So remember, whenever you want to create a 2D array, you have to pass two square brackets, or we can also pass a tuple here like this. Okay, but now I am passing only list. If I run this, the command has been successfully run. To have a look at my 2D array, print a2. So this is my 2D array. Here you can see there are 2 rows and 4 columns, and the number of brackets also here is 2. In earlier 1D array, the number of brackets is 1 only. So that's how you can recognize the array shape. Now if we also check the dimension using ndim, run this, means the dimension of this array is 2. And we can also check the shape. The shape is 2 comma 4, means there are 2 rows. In our first row we have elements 1 2 3 4, and in our second row we have elements 5 6 7 8, and there are 4 columns like this first, second, third, fourth. Okay, we can also check this size. There are 8 elements in this array, as you can see here. So this is the syntax to create a 2D array and checking the dimension, shape and size. To make a note, I have passed the comment here also, like ending command is used for what, shape command is used for what, and size for what. Okay, now we will create a 3D array. Now to create a 3D array, again I will pass a variable name a3 here, and the syntax will be np.array. Here I will pass 3 square brackets because I have to create 3D array, and then I will pass the elements. I have passed the elements for the 3D array like this. My first list 1 2 3, comma my second list 4 5 6, comma my third list 7 8 9. Okay, and notice here we have 3 square brackets. Now if I run this, the command has been executed, and if I print this is my 3D array. You can recognize with these 3 square brackets also. You can also check the type, it is an array. And if we want to check the shape is 133. Now means there is one matrix and there are 3 rows and 3 columns in this array. We can also check the size of this array. The size is 9, means there are 9 elements in this array. So that's how we can create the 3D array, 2D array and 1D array. This is a simple process. Other functions and other features of array we will cover in our next video. Hello friends, welcome to Data Science Lovers. In our last video, we learned about 1D and 2D and 3D as array. In this video, we will talk about zeros array. Zeros array in NumPy. An array in which all the values are 0 are called as zeros array. And the syntax to create a zero array is np.zeros function. np is our NumPy library here. Inside this zeros function, we can use different parameters like shape and dtype. If we talk more about this zero array, then we can define the shape and the data type of zeros array. We can create 1D, 2D as well as 3D zero array. And the default data type here is float. We can change it to integer also. These are 3 different functions that we can use on zero array in NumPy. Now, first of all, we will import the NumPy library, and the syntax will be import NumPy as np. Now, we will create a zero array of 1 dimension, and the syntax will be np.zeros function. In the round brackets, we will pass the number of elements that we want in our array. Here I will pass 3, and I will save this array in a variable named z1. Okay, if I run this, the command has been executed. To print z1, I can write simply z1 here. If you see here, there are 3 zeros, means the number of total elements that we want. All zeros are in float format 0.0.0. Okay, now we can change the data type of this array. np.zeros, again the number of elements that we want in our array 3, and I will use a parameter dtype equal to int. Again I will save this array in my variable z1, the same as above. And if we print this, then you can see now all the elements of this array are in integer format 0 0 0. We can write any number here like 5, then it will show 5 zeros. If we write 15 here, it will show 15 zeros. Okay, we can also check the type of this Z1. This is the function of array type, and here I will pass the variable name Z1. It is showing numpy.nd array. Next, we can also check the dimension of our array, and the syntax will be np.ndim, means number of dimension. Here I will pass my array which is stored in Z1. It is showing 1, means it is an one-dimensional array. Similarly, we can create a 2-dimension zero array, and the syntax will be same as np.zeros function. Here we have to pass the number of rows as well as number of columns in the tuple format, means you can say 2 round brackets we have to include. First of all, I will write number of rows like 3, 4. 3 rows, 4 columns. If I run this, it will print like this. There are 3 rows and 4 columns, and all the elements are 0 in float format. We can save this into a variable Z2, and this is our Z2. Now, if we want this array in our integer format, then as above, we can pass the parameter dtype. np.zeros 3/4 and dtype equal to int, means integer. If I run this, all the elements are in integer format now. Again, I will save this array in a variable Z2 equal to this. These are the comments written for your understanding. If I run this, then this is our Z2. If we want to check the shape of this Z2, then we can use the shape function. Z2.shape. It is showing 3/4, as we mentioned here, 3/4 means 3 rows and 4 columns. Now we can also create a zero array with 3 dimension. np.zeros. Here again we have to use tuple, and first of all we have to pass the number of matrix. I will pass 2, number of rows 3, number of columns 4. If I run this, it will create a zero array of 3 dimension. Means you can see here there are 3 square brackets, means it is of 3 dimension, and also at the end there are 3 square brackets. 3 dimension means there are 2 matrices, number 1 this one, and second matrix is this one. In each matrix there are 3 rows, 1 2 3, 1 2 3, and 4 columns, 1 2 3 4, 1 2 3 4, like this. We will also save this in a variable Z3, and Z3 is this. We can also change the data type of this Z3 also using this dtype integer. Okay, if we want to check the dimension of this Z3, then simply I can write Z3.ndim. It is showing 3, means it is a 3-dimensional array. We can also check the number of elements in this 3D array, and the function that we will use is size. Z3.size. It is showing 24, means there are total 24 elements in this 3D array, and all elements are 0 with float format by default. So that's all for this video. Hello friends, welcome to Data Science Lovers. In our last video, we learned about zeros array. In this video, we will learn about ones array. Ones array. What is this ones array? An array in which all values are 1 is known as ones array. Now, how we can define this ones array? The simple syntax is our NumPy library np.ones function we have to use. And inside this function, we can use different parameters like shape and data type. Means we can define the shape of our array, and we can also define the data type of our ones array. whether float or integer. If we talk more about this once array, then we can define the shape and data type of once array. As I told you, we can create 1D, 2D as well as 3D once array. And the default data type here is float. We can change it to integer also. These are simple 3 basic functions that we can use on any array: name, shape and size. Now first of all we will import the NumPy library. Import NumPy as np. Now we will create a single dimension once array, and the syntax will be np our NumPy library dot once function, and inside the round brackets we have to pass the number of elements that we want in our array. Here if I pass 3 and run this syntax, then it will create a once array where all 3 values are 1. And if you see here, these values are in float format, 1 decimal, 1 decimal, 1 decimal. Okay, and it is showing that it is an array. So that's how we can create a simple once array of 1 dimension. We can save it in any variable like a1 equal to np.once, and we can print this a1. This is our once array of 1 dimension. Now we can change the data type of these elements to integer also. How? Same syntax, np.once function. The number of elements I want 3, and I will use this parameter dtype. Dtype equal to int. Int means integer. If I run this, then you can see all 3 elements are in integer format now. Again we will save this in a variable a1. This is our a1. Or we can use print function. Earlier the default format was in float format, and now we have changed this to integer format. We can also check the type of a1 by using the type function type a1. It is showing it is an array. We can also check the dimension a1 dot and dim. Okay, these are 2 simple functions that we can use on any array. It is showing 1 means it is 1 dimensional array. Similarly, we can create a 2D array, and the syntax will be np.once. Here we have to pass number of rows and number of columns. So we have to pass in the form of a tuple. First of all we have to write number of rows. I want 2 rows and 3 columns. If I run this, it will create an 2D array like this. If you notice here, there are 2 square brackets, first one and second one, in the starting and in the end also. Means it is showing it is a 2D array. We can save this in a variable a2, print a2. Okay, that's how we can create a 2D array, or you can say 2D once array, where the default data type is float. Similarly, we can change the data type into integer format, and the syntax will be np.once. In the round brackets we have to pass number of rows as well as number of columns, and we will use the same parameter dtype equal to integer. We will save in a variable a2, print a2. This is the once array in integer format. All values are 1 here. We can also check the shape of a2 using the shape function a2.shape. It is showing 2 by 3 means 2 rows and 3 columns. Now we will create a 3D array, 3D once array, and the syntax will be np.once. The round brackets here, first of all we have to write the number of matrix that we want in our array. If I want 2 matrix, then we have to pass number of rows in each matrix, 3 rows, number of columns in each matrix, 4. Means I need 2 matrix and the number of rows will be 3 and number of columns will be 4. I will save this in a variable a3, and if we print a3, then it will look like this. Here if you see there are two matrices, first one this all and second one this. Okay, and if you notice again here in the starting there are 3 square brackets, at the end there are also 3 square brackets, means it is a 3D array. We can also change the data type from float to integer using this d type parameter. After this d type equal to all elements, all one are in integer format. Now we can use the endim like this to check the dimension of our A3 array. It is showing 3, means A3 is in 3 dimension. To check the dimension of any array, you can use np.endim and the array variable name, or you can simply use array variable name .endim. There are 2 methods. Next we can check the number of elements in our array, and to check the number of elements in any array we can use the simple size function. 24. It is showing that there are 24 elements in this A3 array in total. So that's all for this video. Hello friends, welcome to Data Science Lovers. In our last video we learned about ones array. In this video we will learn about full array. So what is this full array? An array in which all values are same or constant is known as full array. This is a simple syntax to create an full array in NumPy, and the syntax is our NumPy module, which is denoted by np here dot full. This is the function, full function, and inside this function we can pass 2 parameters and many more like shape and fill value, which is compulsory. These are some points about full array. We can define the shape and pass the value to be filled in full arrays. We can create a 1D or 2D as well as 3D full array, and there may be different data types in these array like integer, float or string as well. And the default data type in this full array is integer, while in ones and zeros array the default data type is float. These are 3 simple functions that we can use on any array: endim, shape and size. Now to start with NumPy array, first of all we have to import the NumPy module, and the syntax is this: import NumPy as np. We will run this. The module has been successfully imported in this Jupyter Notebook. Now first of all we will create a simple 1D full array, and the syntax will be np or NumPy library dot full function, the round brackets, and the first parameter that we will pass the shape of our array. I am creating a 1D array, so I will pass a 3 here, means I need 3 elements in this 1D array, comma, I have to pass the second parameter, which is compulsory, the fill value, means the value that I want to fill in this array. Suppose I pass 79. If I run this, then you can see a 1D array is created where are 3 elements and each element is 79, means this array is filled with a single value which is 79. So that's how we can create a simple 1D full array. We will save this in a variable name f1. Suppose print f1. To print the f1 we will use print function. So this is a 1D array filled with 79 at each position. And if you notice here that the all values are in integer format. This is the default data type for full array. We can create a full array with float data type also. So what we have to do, np dot full function, our first parameter, the shape of the array, suppose 3, our second parameter, the value that we want to fill in this full array, 79, and here we have to pass third parameter d type, means data type for this array equal to float. So when I run this, you can see all the values are in float format now. 79.79.79. Okay, we will save this in a variable f1 again and print f1. So this is our full array with integer format by default, and this is our full array with float data type as we defined here. We can check the type of any array using the type function type. Here we have to pass our array. Our array is stored in f1. I will write f1 here and it will show empty array. To check the dimension of any array, we have to use ending function, and the syntax will be our array variable name f1 here and dim. This is the syntax, or you can say function, to check the dimension of our array. If I run this, it is showing 1, means f1 is a 1D array. Similarly, we can create 2D as well as 3D array. So first of all, we will create a 2D full array, and the syntax here will be np module dot full function. First parameter will be our shape of the array. Here I have to pass number of rows as well as number of columns. So I will pass number of rows 2, and these number of rows and number of columns we have to pass either in the form of a tuple or in the form of a list, like this. The round brackets here means tuple, and if we pass square brackets it will be a list. So our second parameter in the full array, our value. Suppose I am filling a value 50.9, means I am filling it with a decimal value or float value. If I run this, you can see it is creating a 2D array with 2 rows and 3 columns, and at each position we have a value 50.9. Again, we will save this in our variable f2 and print f2 like this. Now, if we want to change the data type of this f2 array, then we can use the dtype parameter. So how we will use np.full function. Our shape 2 by 3 is 2 rows 3 columns. Our value for full array 50.9, and the third parameter here will be dtype, means data type equal to int, means I need integer values in my full array. Here if you see 0.9 has been removed and all the values are converted to integer format. We will save this in f2 and print f2. So we can change either in float data type from integer or either in integer data type from float values using the dtype parameter. We can also change the data type to string as well. See what will happen. np.full, the same 2 by 3, the shape, and 50.9 comma 50.9, and here I will pass dtype equal to str, means string. Str is the short form for string. Here if you see, it is showing quotes against each element, means it is a string value. And if you notice here that it is showing only the first character, or you can say first value only, like from 50 it is showing only 5. We will save this in f2 again. You can choose any variable name. I am choosing f2 for my reference. f2. See here, when we converted the data type to string, it is showing only the first letter or first character of our element. Suppose if I pass here, instead of 50.9, if I pass 5522 like this and run this, then also it will show only first character. If I pass was 9 here, 97. Suppose I want to fill my full array with this value, but data type I have changed to string, and if I run this, then it will show only 9, means the first character of my value, if I am using the string data type. So this is the property of full array. Now we can also check the shape of our array, any array, and the syntax will be F2 our array name, variable name dot shape. If I run this, then it is showing 2 by 3, means there are 2 rows and 3 columns in F2 array. So this is the shape function. Now we can create a full array with string data type of 3 dimension, and the string that we will use here is Python. np dot full the shape of my array. I will pass list here to give the shape. 2 by 3 by 4. 2 means number of matrix, 3 means number of rows, 4 means number of columns. Okay, this is the shape for 3D array. As it is a 3D array, we have to pass 3 values here. The second is the fill value, that is mandatory for fill array, and this time I want to fill with a string value. String value is Python here. If I run this, then this is our 3D array with 2 matrices. Our first matrix, and if you notice here, there are 3 square brackets in the starting and also at the end of this array, means it is indicating that it is a 3D array. Now we will save this in a variable name f3 and print function f3. So this is my full 3D array, and I have used data type as string here, means Python. You can use any string here like this. So it will create a 3D array. And next is we have another method to check the dimension of our array. np dot ndim. In the round brackets we have to pass our array which is stored in f3. It is showing 3, means f3 is a 3-dimensional array. And if we want to check the number of elements in any array, then we can use the size function or size command on any array. I am using size function on f3 array. It is showing 24, means there are total 24 elements in this f3 array. So that's all for this video. Hello friends, welcome to Data Science Lovers. In our last video, we learned about full array. In this video, we will learn about random function, which is a part of random module. In this random module, we will cover different functions like random function. Second is randint function, rand function. Fourth is randn function and uniform function and our choice function. Let's start. What is this random module? The random module contains the functions which are used for generating the random numbers. Now, first of all, we will import the NumPy library in this Jupyter Notebook, and the syntax will be import NumPy as np. Run this. The library has been successfully imported. From this NumPy library, we will import the random module, and the syntax will be from NumPy, our library name, import the module name which we want to import. We want to import random module. We will run this. The command has been successfully executed. Our NumPy library and our random module has been imported in this Jupyter Notebook. Let's first start with the random function. The random function returns the random float numbers between 0 and 1. Let's see how. First of all, we will use the random module, and from this random module we will use the random function like this. If I run this syntax, then it will create a random number between 0 and 1 in the float format. Suppose if I pass random dot random, if I pass any value here in this random function like 4, then it will give, or it will generate 4 random values all in float format between 0 and 1, and it will be in array format, and it is a 1D array. Similarly, if I want to create a 2D array with random numbers, then what can I do? I can write like this. I will pass the number of rows and number of columns for 2D array. 2 is my number of rows and 3 is number of columns. If I run this, then it will create a 2D array where there are 2 rows and 3 columns, and all the values in this 2D random array are float format between 0 and 1. Similarly, we can create a 3D array also, or you can say 3D random array. Our numpy library dot random, this is our random module, and in this module we will use random function. This is our random function, this one. Okay, here I will pass 3 values. First one for matrix like 2, then second one for rows, number of rows, and third one for number of columns. So I need 2 matrix. In each matrix there will be 3 row and 5 columns. If I run this, then it will create a 3D array all filled with random numbers, and all numbers are in float format between 0 and 1. There are 2 matrices. First one is this matrix, second one is this matrix, and in each matrix there are 3 rows. First one, first row, second row, third row, and first row, second row, third row, and 5 columns. And if you notice here, there are 3 square brackets in the starting here, and at the end also there are 3 square brackets, which indicates that it is a 3D array. So that's how we can create random arrays 1D, 2D or 3D using the random function. Next is randint function. The randint function generates random integer numbers between the given range. By default, the range here starts from 0, and if we use randint function, then the numbers generated can repeat. Let's see how it works. We will write our numpy library and then our random module. After random module, we will use randint function. If I pass 2, 13, then it will generate a random integer number between the given range. The given range is 2, 13, means it will generate a random integer number between 2 and 13. Suppose I need 5 random numbers between 2 and 13. Then I will use randint function 2, 13, my range, and after this I will pass the number of elements that I need. Suppose I need 5 elements, and if I run this, then it will give us 5 random numbers between 2 and 13. If I run this again, then you can see the numbers are repeating, means 12 is present 2 times. Now suppose I pass only one value here in the randint function. Suppose I pass 4, then it will generate a random integer number between 0 and the end range is 4, means by default the range starts from 0 and it will end at the given number. So if I run this again, then it is giving now 3. So this is the second property of randint function, that is the range starts from 0. Next is rand function. The rand function returns the random float numbers between 0 and 1. It is, you can say, similar to this first one, the random function, but there is little difference. Let's see what is the difference. To use the rand function, we will first of all use numpy library, then random module, and then rand function. If I run this, then it is stated here that it will return a float number between 0 and 1. So it is returning a single float number. And if I use random.rand, if I pass any value or parameter here like 4, then it will return 4 random numbers between 0 and 1 in the form of 1D array. Similarly, we can create a 2D array of random numbers using rand function like this. I will pass here number of rows and number of columns. 2, comma 3. Means I need 2 rows and 3 columns. If I run this, it will create a 2D array and all the values are in float format between 0 and 1, and there are 2 rows and 3 columns. Similarly, we can also create a 3D array using rand function, and this time I need 2 matrix, 3 rows and 5 columns. If I run this, then it will create a 3D array which is represented by these square brackets, 3 square brackets at the start and 3 square brackets at the end, and there are 2 matrices. In each matrix there are 3 rows and 5 columns. Now if you see here, this rand function and this random function. In random function, to give the dimension, we are using the tuple. Tuple means you can see there are round brackets around this dimension 2, 3. Also here there are round brackets. Means double round brackets are here. But here in rand function, there are only single round brackets. Like this. Means we can pass the number of rows and number of columns directly inside the rand function. So this is the little difference between rand and random function. Next is rand function. The rand function returns the random float numbers, positive and negative both, in the form of array. It is just similar to above this rand function. The difference is it can create the negative random numbers also. Let's see how. np.random. After this, we will use rand function like this. If I run this, then it is creating a float number, and this is a positive float number. If I run this again, then you can see this time it generated a negative float number. And if I pass any value here inside the rand function, like if I pass 4 here, then it will create 4 random numbers, positive and negative both, in the form of 1D array. Similarly, we can create a 2D array, rand n. Here I will pass the number of rows and number of columns, and if I pass here 3, 5, I need 3 rows and 5 columns, and our values can be positive as well as negative in this array. So it is creating a 2D array with 3 rows and 5 columns. All values are in float format. We can also create a 3D array, np.random.rand and number of matrix 4. If I pass number of rows 2 and number of column 3. If I run this, it will create a 3D array. In this array we have 4 matrix, 2 rows and 3 columns in each matrix. And you can notice here that the values are in float format, and we have positive as well as negative values in our array. So this is the use of rand function in the random module. Next we have is uniform function. The uniform function returns the random float numbers between the given range of values. Here the random numbers cannot repeat, and by default the range starts from 0, and if nothing is passed in the function, then it will return a float number between 0 and 1. Let's see how it works. np.randommodule.uniform function. Okay, if I pass here 2, 5, I am giving a range from 2 to 5. If I run this, then it will create a random number between 2 and 5, and it is in float format. Suppose I need 17 random numbers between 2 and 5. Then I will pass 17 as my third value here. If I run this, then it will return 17 random numbers in float format between the given range, which is 2 to 5. And you can see it is in the form of 1D array. Now if I pass only one value here, np.random and uniform function. Inside this function, if I pass only 5, only single value, then it will return a random float number between 0 to 5, because by default here the range starts from 0. And the one thing you have to notice that 5 is not included here. If I run this again, then it is generating a float random number 1.2. If I run this again, then it will create a again random number between 0 to 5. Suppose if I pass nothing inside this uniform function like this, I am not passing any value here, then it will return a float number between 0 and 1. Okay, so this is the uniform function. Next, move to the choice function. About choice function, the choice function returns random integer numbers from the given sequence. Here we are talking about sequence. In our last functions we were talking about the range, so we will see the difference here. And the second point is the range starts from 0 by default. If only one element is passed, then it will return a random number between 0 and that element. And the last point is by default replace equal to true, which means the numbers can repeat. We will see all 4 points one by one. Now if I use random module and the choice function, inside the choice function we have to pass any sequence here. Suppose I pass any sequence, random sequence. Here I am passing random values like this. So suppose this is my random sequence here. If I run this, then it will return any random number from this sequence. And I will copy this syntax. If I paste, and suppose I need two random numbers from this sequence, then I will pass this size as 2 here and run this. Then it will return two random numbers from the given sequence, and it will be in the form of 1D array. I can use 5 also here, then it will return 5 random numbers from the given sequence. If we talk about our second point, which is the range starts from 0 by default. What is mean? np.random module, the choice function. If I pass here like 13 and 123, what the syntax will do? This syntax will create 123 random numbers between 0 and between 13. Means 0 to 13, it will create 123 random numbers, and the numbers you can see can repeat. Okay, because all values have to be integer here, so there is a repetition. Next, if I pass only one element in the choice function, np.random.choice, if I pass only one value like 12, then it will give me, or it will return a random integer value between 0 and that element. Element is 12, means it will return a random integer value between 0 and 12. Next point is by default replace equal to true, which means that the numbers generated can repeat itself. I will copy this syntax np.random.choice, and we have a sequence here. And if I pass any size here, size is our parameter equal to 5. If I run this, then it will give 5 random numbers from this sequence, and the numbers can repeat. You can see 33 is present 2 times. By default, it means replace equal to true. Replace is a parameter here. If I pass replace equal to false, then there will be no repetition in the generated numbers. If I run this syntax, every time there will be no repetition because the parameter replace is passed as false. Now suppose if I pass size as, you can say, 20 here, but our sequence is containing how much elements? 1, 2, 3, 4, 5, 6, 7, 8, 9. Our sequence is containing 9 elements, but we are asking for 20 elements from this sequence. And we are also asking that there should be no repetition. If I run this, then it will show an error because we are asking for the elements greater than the size of this sequence. If I pass through here, then means we are asking that there may be repetition from our sequence. If I run this, then it will create 1D array of 20 size from our given sequence. So this is the difference by passing replace equal to true and by passing replace equal to false here. So this is our random module from NumPy library. It may be confusing for you if you're starting from zero, but you have to note down these points which I have mentioned here for you, then it will be more clear to understand. So that's all friends for this video. Hello friends, welcome to Data Science Lovers. In our last video, we learned about the random module. In this video, we will learn about the linspace function. So let's start. The linspace function in NumPy returns the evenly or you can say linearly spaced value within a given interval. Maybe this statement is not clear to you as of now, but it will be clear later. This is a simple syntax to use the linspace function. First of all, we have to use our NumPy library. Then we have to use the linspace function. And inside this linspace function, we have different parameters. First one is start value. Second is stop value. Then we have number or you can say num. And we have the endpoint parameter, reg step and data type, which is denoted by d type in short. Here one thing you have to note that by default the linspace function shows 50 values. It will be clear later to you. As it is a part of NumPy library, first of all we will import the NumPy library in this Jupyter Notebook, and the syntax is import NumPy as np. Now I will use linspace function. As per this syntax, we have to use NumPy library np dot linspace. Our first parameter is start value. Suppose I give a start value of 2. Next parameter is stop value. I will give a stop value, suppose 20. Third parameter is number. Number means how many numbers we want in our output. Suppose I give number equal to 10, means I need 10 numbers in my output. I will save this in a variable name a for my reference. You can give any variable name to this. If I run this, the command has been successfully executed. Now let's see what is gives in output when I print a. The output is this. Here if you see that the start value is 2 here as we mentioned here, and the stop value is 20 as mentioned here, and all the 10 numbers are linearly distributed between these two values that we passed in the linspace function. It means that between every two numbers, first and second, second and third, third and fourth, the difference is equal. Here you can see there is a difference of 2 between every two numbers. 10 to 12 there is a difference of 2, and 18 to 20 there is also a difference of 2. Okay. Our next parameter is endpoint. Let's see how to use this. I will copy this or I will write it again. np dot linspace. Our start value 2, our end value 20, and number again I will pass 10. And this time I will use another parameter endpoint equal to false. I will save this again in a variable name a. Now if I print a, you can see that 20, which is our endpoint, or you can say the stop value, is not in this sequence or in this output. Why? Because we have given the endpoint equal to false. Means we don't want to show, or we don't want to generate the endpoint in our output. Now what will happen if I pass endpoint equal to true? Let's see. I will copy the syntax and paste here, and this time I will pass endpoint equal to true. If I run this and if we see the output of A, then you can see this time the end value 20 is also showing here. It means the endpoint is true by default in this linspace function. If we don't want to show the stop value or the last value, we can pass endpoint equal to false. Okay, this is the difference between true and false for endpoint. Next parameter we have is let step. Let's see how it works. I will again use linspace function. My start value 2, my stop value 20, number I will pass again 10, and endpoint equal to true, which is already true by default, but I will pass for your reference here, and this time I will pass a parameter let step as true. Save this in a variable name a, small a, and if I print this a, then you can see there is additional value here, which is 2. This 2 is the step value between every two values of this sequence. If you see here, the difference between first value and the second value is 2. Similarly, the difference between the second value and third value is 2. And 2 is the step value, or you can say difference between every two values. So this is the let step. When I give let step equal to true, it is showing the step value, and when I pass let step equal to false and we print again a, then it will not show the step value of 2. And also notice one thing here, the output when we use let step equal to true is shown in the form of a tuple, which is denoted by these two round brackets, and when we put let step equal to false, the output is in the form of a 1D array. Okay, moving to our last parameter, which is d type or data type. I will copy this, and if I paste here, and this time I will use the another parameter d type equal to int, or you can say integer. I will run this, and when I print a, you can see all the values are now in integer format. Earlier by default all the values were in float format 2.4.6. Now the all values are in integer format 246. So we can change the data type of our values in the output. We can also pass the data type as a string if we want to use anywhere, like this print a. Then it will convert all the values in the form of a string, and if you notice it is denoted by these quotes around each value. Now one note was mentioned here, by default the linspace function shows 50 value. What does it mean? Suppose I copy this syntax, or I will write it again here, np dot linspace, we will pass our start value as 2 and our end value as 20. Save this in a variable name a, run this and print a. When I print this, then you can see it is showing 50 values between 2 and 20. Our start value is 2 and our last value or end value is 20, and between these two values there are total 48 values more, and in total there are 50 values. So this is the meaning of this note. By default it shows 50 values. When we pass here this parameter num, or number and give any value to it, then it will show only the specified count of the values. Here we haven't passed the parameter num, so it is showing 50 values by default. If I pass num equal to suppose 24 and run this, and if I print a, then it will show 24 values between 2 and 20, and all values are linearly distributed. Okay, and if I want to check that what is the step value between these two values, then I can use the parameter that is step equal to true. If I run this, then you can see the step value between every two value is this 0.78260. So that's how we can use the linspace function in NumPy. Hello friends, welcome to Data Science Lovers. In our last video, we learned about the linspace function. In this video, we will learn about the empty function in NumPy library. First of all, we will go through the definition of empty function. Then we will see the syntax. Then we will create the 1D empty array, the 2D empty array, and 3D empty array. Let's start. What is this empty function in NumPy library? The empty function is used to create an array of arbitrary values, or you can say random values, of the given shape and data type. The shape and data type will be defined by the user without initializing the entries. So this is the simple definition of empty function. Now this is the syntax. How can we use the empty function? We have to use NumPy library, which is denoted by NP as short form. Then we have to use empty function. In this empty function, we have two parameters. The first parameter is shape and the second parameter is dtype or data type. These are the 2 points about empty function. First one is the shape can be given in the form of list or in the form of tuple. And the default data type for this empty function is float. Now, first of all, we will import the NumPy library in this Jupyter Notebook. And the syntax is import NumPy as NP. NP is the short form for NumPy library we are using here. When I run this, the command has been successfully executed and the library has been imported in our Jupyter Notebook. Now, first of all, we will create a 1D empty array. So, as per our syntax, first of all, we have to use our NumPy library, NP, then empty function, and our first parameter is shape. Here, I am defining the shape as 5 only because we have to create a 1D array. So this is the simple syntax to create a 1D empty array. We will save this in a variable name a for our reference, and when I run this, the command has been executed, and when I see the output of a, then you can see it is a 1D array with 5 random values, the first values, comma second value, comma third, comma fourth and fifth. All values by default are in float format. Now, if you want to create an empty array with integer data type, then we can make use of our second parameter, which is dtype. So np.empty, our first parameter shape 5, and here I can define the data type, which is denoted by dtype, in short, data type equal to int. And again I will save this in a variable name a. When I run this, the command has been executed, and when I have a look at a, then you can see all the 5 values are random and all the 5 values are in integer format now, because we have defined the data type as integer here. Similarly, we can define data type as object also, and again we will use NumPy library, the empty function, our shape 5, and our second parameter dtype equal to, here we have to use object because we have to create an array with object data type. I will save this in a variable a. The command has been executed. When I print a, you can see data type is mentioned as object here, and it will always show none, 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 none. Okay, so whenever we will use data type as object, it will show none for each element or against each value in the array. And the one thing you can note here is it is a 1D array which is denoted by this single square bracket. This one single square bracket denotes that it is a 1D array. So that's how we can create a simple 1D empty array. Now second is we have to create a 2D array using empty function, and the syntax will be somehow same as our first syntax, np.empty. Here we have to pass the shape, and for shape we need number of rows as well as number of columns. So we will pass either in the form of a tuple or either in the form of list. The round brackets here define the tuples. First of all, in the tuple I will pass number of rows as 5 and number of columns as 3. And I will save this in a variable name b for our reference. When I print b, you can see it is creating an empty array with 5 rows and 3 columns. And if you notice here again, there are 2 square brackets in the starting as well as in the end there are 2 square brackets, which denotes that it is a 2D array. Also, if you notice that the value are in float format now, 0 point 0 point. If you want to change the data type of this array, then again we can use data type parameter np.empty. First of all, I will use my first parameter shape 5 by 3, 5 rows, 3 columns, and second parameter dtype equal to int. We will save this in variable b, and when I run this variable b, you can see now there are all values in integer format now, means the decimal is not there. Also, it is created a value of 1536 because as per our definition it creates an array of arbitrary values, or you can say random values. So it can create an array with any value. Similarly, we can create a 2D empty array with object data type. Syntax will be same, np.empty, and our shape 5, 3, and this time if I pass dtype equal to object, and again I will save this in a variable b, and when I print b, then you can see data type is object here now, and when I use data type object, then it is showing all value as none, and there are 2 square brackets indicating that it is a 2D array. So that's how we can create 2D empty array with float, integer, and object data type. Now we will create a 3D empty array. 3D empty array means there is a matrix, number of rows and number of columns. So the syntax will be np.empty function, our first parameter shape, and if you notice here that this point shape can be given in the form of list or in the form of tuple. Okay, when we were creating a 2D array, we were giving the shape in the form of tuple, which is denoted by these round brackets. Now we will create a 3D array and we will pass the shape in the form of list using the square brackets. So first of all, I have to pass the shape. I will use square brackets, and in a 3D array, first of all I have to pass number of matrix. I am passing 2. Then we have to pass number of rows. I am passing 5. Then we have to pass number of columns. I am passing 3 here. So this is a simple syntax to create a 3D empty array. Okay, we will save this in a variable name c, and if we print c, then you can see it is a 3D array with all values in float format by default as per our definition. Okay, and there are 2 matrix. This is our first matrix and this is our second matrix, and in each matrix there are 5 rows and 3 columns. Now we will change the data type here, and np.empty, our shape 2 by 5 by 3, and dtype equal to we will create a 3D empty array with integer data type. So I will pass int here, which is the short form for integer, and save this in variable name C. And when I print C now, all values are changed to integer format now. Okay, although it is showing 000, means it can show random values. If I run it again and print C again it is showing 000, but when you run it in your notebook, then it will show some different values, different random values. Similarly, we can create an empty 3D array with object data type. The syntax will be almost same. np.empty, our shape 2 by 5 by 3, and d type equal to object. We will save this in a variable name C, and when I run this, you can see it is a 3D array which is denoted by 3 square brackets in the starting and 3 square brackets at the end. It is showing the data type as object also, and when we are using data type object, it will show all values as none. So that's how we can create a 3D empty array with float, integer and object data type. Hello friends, welcome to Data Science Lovers. In our last video, we learned about the empty function. In this video, we will learn about the I function in NumPy library. We will start with the basic definition of the I function. Then we will see the syntax. We will create a simple I array. Then we will create the I array with main diagonal, the upper diagonal and the lower diagonal. And we will change the data type to integer. Then we will create I array with different number of rows and different number of columns, 4 by 5 and 5 by 4, and then we will see some additional examples of I array. Let's start. The I function returns a 2D array with 1 on the diagonal side of this array and 0 elsewhere. The syntax is simple. First of all, we have to use NumPy library, which is denoted by np here, dot I function. In this I function, the shape of the array is mandatory, while these two parameters k and d type are optionals. K represents the index of the diagonal and d type represents the data type of the values. Kindly note these 3 points, which will be clear by doing some examples. Here, if only number of rows is passed, then the number of columns of the array will automatically become equal to the number of rows. Okay. K is the index of the diagonal, and by default k equal to 0 means we will represent the main diagonal, and when k is positive it will represent the upper diagonal, and when k is negative it will represent the lower diagonal. And the third point is the default data type for this array is float. First of all, we will import the NumPy library, and the syntax is import NumPy as np. We will run this, and the library has been successfully imported in this Jupyter Notebook. Then we will create an array of shape 4 by 4, means we need 4 rows and 4 columns, for example. So we have to use the same syntax, np.I function, and inside this I function the shape parameter is mandatory, so we have to pass the shape, and I am passing only one value here, suppose 4. We will save this in a variable name a. Okay, when I print a, then you can see an array of shape 4 by 4 is created, and 1 is present on the diagonal of this array and 0 is present on other places. Okay, so here if you notice the first point, if only number of rows is passed, here I passed only 4, then number of columns will become equal to number of rows. I have passed only number of rows 4, then the number of column has also become 4. So this is the property of this I function. And also notice that it is a 2D array which is represented by these two square brackets in the starting, also at the end of this array. So that's how we can create a simple I array with same number of rows and same number of columns. Now we will use our second parameter, which is k, which represent the index of the diagonal. Again, np.I function, our shape of the array 4. This time if I write k equal to 0, k equal to 0 represents the main diagonal. What is this main diagonal? We will save this in a variable a, and when I print a, then the output of this array is similar to our previous array output. Why? Because the value of k is 0 by default, as we notice here. Okay, and when k is 0 means it will represent our main diagonal. Our main diagonal is that will start from index 0 of the array and will be in the middle of the array. Now in any case, if we want to represent the upper diagonal of this array, then we can give a positive value to k. np.I, our shape 4. This time I will pass k equal to 1, which is a positive value, and we will save this in a variable b. When I print b, you can see that the position of the diagonal has changed. Now it is starting from our first index, this one, 1 1 1. So this is how we can create an I array with upper diagonal. Similarly, we can create the I array with lower diagonal, and the syntax will be np.I function, our shape, and this time we have to pass k as a negative value. I will pass k equal to -1. We will save this in a variable c, and when I print c, then you can see that the diagonal is started from this place, 1 1 1. So this is the difference between the main diagonal, where the 1 will be in the middle of the array, and this array is with upper diagonal, and this array C is with lower diagonal. We can also change the data type of the values. By default, the data type is in float format. We can change it to integer also. So np.I function, our shape, and I am not using the k parameter now. I am using data type equal to int. Int is a short form for integer. We will save this in a variable named d, and when I print d, you can see all the values now are in integer format, and 1 is present at the main diagonal of this array. And now we can change the shape of the array. We can have different number of rows and different number of columns as well. np.I, first of all we have to pass number of rows. Suppose I pass 4 and then I pass 5. So 4 will become my number of rows and 5 will become my number of columns. We will save this in a variable e, and when I print e, you can see this array is 2D and it is containing 4 rows, 1 2 3 4 and 5 columns. And here, as the number of rows and number of columns are different, that's why the 1 is present in all rows but not in all columns. The last column, which is extra, doesn't contain the 1 value. It is containing only 0. If we create an array of shape 5 by 4, means I need 5 rows and 4 columns. And we will save this in variable f. When I print f, then you can see 1 is present in all columns but not present in all rows. What does it mean? What is the difference here? If the number of rows is less than the number of columns, then 1 will be present in all rows, and if the number of columns is less than the number of rows, then 1 will be present in all columns. And the condition here in both cases, that k must be equal to 0. K equal to 0 for both the conditions. Now we will see some additional examples of the I array using I function. First one is np.I. If I pass only one value, which is 1, then what will be the output? You can try in your notebook also. When I run this, it will represent only one value in float format, and this is a 2D array. Next is np.I. When I pass 12, what will be the output? then it will create an array of 12 by 12 and the main diagonal will contain the value 1 and all values are in float format. Next we can use an example np dot I 6 number of rows, 9 number of columns, and here I am using the parameter k and I am passing k equal to 3. It is a positive number. Also we will use the second parameter, or you can say third parameter, dtype, and dtype equal to integer. When I run this, then you can see all the values are in integer format and there are 6 rows and 9 columns, but the diagonal or the value of 1 is starting from this position, or you can say the third index. Okay, this is our 0th index, the first index, and second index, and the third index, because we have passed k equal to 3. And as I told you in above examples, then whatever the less number, either number of rows or number of columns, one will be present accordingly. The number of rows is less here, so one is present 6 times only here in all rows but not present in all columns. These 3 columns doesn't contain the value of 1, all are 0. Next example, we can use np.I and 5 the shape, and dtype we can use the data type as string also. We will save this in a variable name small a, and when I print a, then it will show like this. All values are in quote now, which represent the string, but 0 is not shown here, only 1 is shown as string. Okay, and we can also check the dimension of any array using ndim function, which I have told you in my last videos. Ndim, and here we have to pass our array. Array is stored in a. When we run this, it is showing 2, means our array a is a 2-dimensional array represented by these 2 square brackets. So friends, that's all for this video. Hello friends, welcome to Data Science Lovers. In our last video, we learned about the I function in NumPy library. In this video, we will learn about the identity function. First of all, we will see the definition of identity function, then the syntax. Then we have to import the NumPy library, and we will create a simple identity array of 4 by 4. And then we will use the integer data type for this array. We will check the dimension, shape, and size of our array, and we will multiply our array with an integer value and a float value, and we'll see the result. Let's start. The identity function. It returns an identity array, or you can say a square array with 1 on the main diagonal, and at all other places there will be 0. This is the simple syntax of identity function. From NumPy library, we have to use identity function, and inside this function we have 2 parameters, the shape and data type. These are few points about this function. First one is it takes a single integer value only as a shape. Okay, and the number of rows and number of columns will be equal to the given integer value. This integer value will become our number of rows as well as number of columns. And the default data type for this array, identity array, is float. Now, first of all, we will import the NumPy library in this Jupyter Notebook, and the syntax will be import NumPy as np. The library has been imported in this Jupyter Notebook. First of all, we will create an identity array of shape 4 by 4. As per our syntax, we have to use NumPy library, then identity function, and we have to pass our first parameter shape, which is mandatory, while our second parameter dtype is optional. So I have to pass the shape, and for shape I have to pass only a single integer value. If I pass 4 here, This is how we can create a simple identity array. We will save this in a variable name A, and when I print A, you can see it is printing a 2D array of shape 4 by 4, and as per our definition, on the main diagonal 1 is present while all other elements are 0 here. For your reference, if we go through these 3 points, then first is it takes a single integer value only as a shape. So we have passed 4 here. Second is the number of rows and number of columns will be equal to the given integer value. So here the number of rows as well as the number of column will become equal to 4, which is our integer value. And last is the default data type is float. As you can see, all values of this 2D array are in float format. Now we will create the same identity array with integer data type. So how to create a NumPy library, then identity function, and we have to pass the shape. Here I pass 4, and we have to change the data type. So I will use the dtype parameter here, and we will put dtype equal to int, means integer. We will save this in variable b. It is showing error. We have to pass the right spelling identity, and when I print b, you can see all the values are now in integer format, and the shape is 4 by 4. 1 is on our main diagonal and 0 elsewhere. So that's how we can create the data type also for the array. Now we can also check the dimension of our array A. This is our array A, and to check the dimension, we have to use the endim function or endim command. Our array name A dot endim. When I run this, you can see it is showing 2, means it is a 2D array. We can also check the shape of our array A, and the command is A, our array name dot shape. It is showing 4 by 4. Our array is of 4 columns and 4 rows. We can also check the size of array, and the command is A dot array name dot size. It is showing 16, means there are total 16 elements in our array A. We can also multiply our arrays with integer or float values. How? First of all, I will print A here again, and when I print our array A with an integer value of 21, what will be the output? You can run in your Jupyter Notebook also. When I run this, you can see all the values are multiplied by 21. On our diagonal, there are all values 21 because it is multiplied by 1, and other values are 0. Similarly, we can multiply our array with a float value. Suppose I pass 3.1239 like this. When I run this, you can see all the values are multiplied by this float number, and this is the output as expected. So that's all friends for this video. Hello friends, welcome to Data Science Lovers. In our last video, we learned about the identity function. In this video, we will learn about the zeros like, ones like, and full like arrays. First of all, we will see ones like array and syntax, and we'll do some examples. Then we have zeros like array with syntax and some examples. And at last, we have full like array with syntax and some examples for this. If you like our NumPy playlist, kindly subscribe to our channel for more videos. Let's start. First of all, we have to import the NumPy library in this Jupyter Notebook, and the syntax is import NumPy as np. From this NumPy library, we will use the random module, and the syntax will be from NumPy import random. The NumPy library and the random module has been successfully imported in this Jupyter Notebook. Now, first of all, we will talk about the ones like array. The ones like array returns an array of ones, means all the elements will be 1 with the same shape and type as of the given array, means the shape and the type of this ones like array will be same as the given array that we will pass in the function. Let's see how. This is the simple syntax of ones like array function. From NumPy library, we have to use once underscore like function, and inside this function there are two parameters that we can use. First one is our array that we have already created, and this parameter array is mandatory, and second parameter is optional, which is d type. D type means data type, in case we want to change the data type of our new created once like array. Okay, now first of all we will create a simple 1D array, and the syntax will be from numpy library the array function, and inside this function we have to pass the elements that we want in our array. Suppose I create an array with 3 elements like this. I will save this in a variable a. When I print a, then this is our 1D array with 3 elements. Now I want to convert this array a in a once like array. How can I do? As per our syntax, we have to use numpy library, then once like function, and our first parameter is array, means that we have already created. This is our array a. I will use this a here. Okay, and we will save this in a variable name b. When I print b, then you can see all the values, all 3 elements of this array a are now converted into 1. This is the once array. Now I think this definition is clear to you. It returns an array of ones, all values are ones here, with the same shape and type. Here our last array shape is 3 and type is integer. Here also in our new created array, the shape is 3 and type is integer. Now we will do one more example. Suppose from the random module I create a random array of shape 3 by 4. I am creating a 2D array 3 by 4. Okay, we will save this in a variable c, and when I print c, this is my 2D array with random values. Here are 3 rows and 4 columns. All values are in float format by default. Now we will convert this array c in a once like array using once like function, and the syntax is np dot once like our array we want to convert c. Okay, we can also give second parameter data type, which is optional, but I am not passing here, and we will save this in variable d, and when I print d, you can see all the elements of array c now converted to 1, and as all the elements were in float format, in our new array also the element 1 is also in float format, and the shape of our array c was 2D, so our shape of array d is also 2D. Now if we want to change the data type of our array d, then we can use our second parameter d type, and the syntax will be same, np dot once like our array c. This time I will pass parameter d type equal to int. We will save this in variable d, and when I print d, you can see the shape is same, which is 2D, but the data type of the elements is now converted to integer format. Earlier it was in float format. So that's how we can change the data type also in once like array. Next we have is zero like array. The zero like array returns an array of zeros as cleared by this name, the same shape and type as of the given array. This definition is similar to the our once like array. And the syntax is from numpy library we have to use zero like function. Inside this function there are two parameters, array and d type. So let's see how we can work on zeros like array. We will take our array a for the reference. This is our array, 1D array with 3 elements. We will convert this array a in zeros like array, and the syntax will be np dot zeros underscore like function. Here we have to pass our array, which is a. We will save this in b, and when I print b, you can see all the values, all the elements of array a are now converted into 0, and the shape is same, as our array A, which is 1D. So that's how we can create a zeros array from an existing array. We will do one more example. Suppose I create a random array using the random module np dot random dot rand function I am using this time, and we have to pass the shape 5 by 2. If you learn about the random module, then you can watch this video. Here we will save this in C. When I print C, you can see it is a 2D array of shape 5 by 2 and all the values are random in float format. Since we use the rand n function, the values are positive as well as negative in this array. Now we will convert this array C in a zeros array, and the syntax will be np dot zeros like our array name C. We will save this in a variable d, and when I print d, you can see all the elements are now converted into 0 with float format, and the array dimension is 2. It's a 2D array. Now we will change the data type of this array d using the dtype function, and the syntax is np dot zeros like our array C, and our second parameter dtype equal to int. We will save this in D only, and when I print D, then you can see all the elements are now integer format. So that's how we can create zeros like array with float format by default and in integer format by changing the data type. Next we have is full like array. The full like array returns a full array of constant element with the same shape and type as of the given array. Let's see, this is a syntax np dot full like. First parameter is array, mandatory. Second parameter is fill value, which is also mandatory. And third parameter is dtype, which is optional. Again, we will take array A for our reference purpose. This is our array A, and we will convert this array A in a full like array using this syntax. np dot full like. First parameter our array, I am using A array. Our second parameter mandatory is fill value. Suppose I want to fill this array with a value 7, integer value 7. We will save this in B, and when I print B, you can see all the values are now converted into a constant element, or you can say constant value of 7 that we passed here. So that's how we can create a full like array also using full like function. Let's take one more example. Suppose I have a random array from random module. I am using randn function, and if I create a 3D array of matrix 2, 3 rows and 4 columns, we will save this in C, and when I print C, this is our 3D array, which is represented by these 3 square brackets in the starting and also at the end. We have 2 matrices and 3 rows and 4 columns in each matrix. Now we will convert a array C in a full array, and the syntax will be np dot full like our array name C and our second mandatory parameter, which is a full value. Suppose I pass 71 here, and we will save this in D, and when I print D, all the elements are now converted into 71. But by default, all the elements are in float format here. You can see 71.71. Okay. If you want to change the data type of this array, as we did earlier, np dot full like here our array. Suppose this time I want to fill this with a negative value of minus 71. Also, I want to change the data type to integer, so I will pass int here. And if we save this in any variable, suppose E, and when I print T, all the elements of our array C now converted into a negative value of minus 71, and the shape will remain same, which is 3D. So this is simple, friends, creating full like array zeros like array and ones like array. The syntax is almost same. Hello friends, welcome to Data Science Lovers. In our last video, we learned about zeros like, ones like and full like arrays. In this video, we will learn about the diagonal function to create the diagonal arrays. First of all, we will see the definition of diagonal function and its syntax. Then we will use diagonal function on a 2D array as well as on a 1D array. And then we will talk about the k parameter of this diagonal function. And at last, I have a question for you. Let's start. Diagonal function. The diagonal function is used to extract the diagonal elements of an array, or it can be used to construct a new diagonal array. This is the simple syntax of diagonal function. We have to use NumPy library. From this NumPy library, we have to use diagonal and the short form is DIAG. Here in this function, we have two parameters. First one is a means array and it is a mandatory parameter we have to use. Second one is k, which is an optional parameter. Here you have to note 3 points. First one is if a means our array is a 2D array, then the diagonal function extract the diagonal elements of this 2D array. Second point is if our array that we have passed in diagonal function is a 1D array, then it constructs a 2D array with the elements of a on the diagonal of the new array. These points will become clear as we will do some example. And third point is by default k is 0. We can use the value of k greater than 0 while considering the diagonals above the main diagonal, and we can consider the value of k less than 0 while considering the diagonals below the main diagonal. First of all, we will import the NumPy library, and the syntax, as you know, import NumPy as np. The library has been successfully imported in this Jupyter Notebook. First, we will consider an example of 2D array. So I will create a 2D array of size 3 by 3. This is my simple 2D array. I will save this in a variable a for our reference. And when I print a, this is our 2D array of size 3 by 3. Now, if we check the dimension of this array, then we can use the ending function on this. It is a 2D array. Now we will use the diagonal function to extract the elements of this array, and it will extract the diagonal elements. How we will do? We will use our NumPy library dot diag diagonal function, and inside the bracket, as per our syntax, we will pass our first parameter, which is a. A means array. Our array is stored in this variable a, and when I run this, you can see the output is 159. Here 159, these three elements are present on the diagonal of this 2D array. So that's simple how we can extract the diagonal elements of a 2D array using the diagonal function. Now we will use diagonal function on a 1D array. Suppose I create a simple 1D array. This is my simple 1D array. I will save this in another variable named b for our reference. When I print the b, this is the output. We can check the dimension of array b also. B dot ending. It is a 1D array. Now using this 1D array, we will construct a 2D diagonal array. And this new array will consist of all the elements of this array b. How we will do? We will simply use numpy dot diagonal function again, and here we have to pass our array b. Now you can see all the elements of 1D array 1, 2, 3, 4, 5 are now present at the diagonal side of this new array, and all the other elements are 0. If you see the dimension of this new array, then it is a 2D array. 2 square brackets means 2D array. So that's how we can use the diagonal function on a 1D array and construct a 2D diagonal array with this. Now we will use our second parameter, which is k. I will consider this simple array. For example, This is my 2D array. Okay, now we will use diagonal function np.diag, and our first parameter array, we are using a array, and this time if I write k equal to 0, if we see the output, then it is showing 159 in the form of a 1D array. This output is same as our above output, where we haven't used the second parameter k equal to 0. It means that by default the value of k is 0 in this diagonal function. This is our third point also. By default k is 0. Now we will use k greater than 0. Let's see what will change. I will use np.diagonal function again, our array a, and suppose if I write k equal to 1. When I run this, you can see this time it is showing only 2 and 6. Means it is not considering the main diagonal, it is considering the upper diagonal, and the values are 2 and 6. Here also 2 and 6. If I write k equal to 2, then what will be the output according to you? Okay, when I run this, it will show only 3. Means it will consider one more upper diagonal. Okay, so that's how we can change the value of k. Now again, if I use diagonal function on this same array, but this time I give the value of k as negative. Suppose I give -1, then what will be the output? Output will be 4, 8. Means the lower diagonal, the lower side of the main diagonal, and the values are 4 and 8. Similarly, if I use k equal to -2, then it will show output as 7 only. So when k is less than 0, it will consider the lower diagonal. Now we will consider our 1D array with k parameter. I will copy this array again. B is our array. This is B, our 1D array with 5 elements in this. Okay. Now I will use diagonal function again. np.diag, our array B. This time I am considering the B array, and when I use k equal to 0, by default it will show like this. All the elements of our array B will present at the diagonal side of our new array, and all other elements will be 0. And this output is similar to our above output here, where we haven't used k equal to 0. So this is satisfying our third point, that by default the value of k is 0 and the elements will be at main diagonal. Now suppose if I use our array B, and if I use now k greater than 0, suppose if I use k equal to 2, then you can see at main diagonal the values are 0, but the values of this array B are now shifted to the second index from the main diagonal, because we have used k equal to 2. If we used k equal to 1, then it will move only one side upper from the main diagonal. But we have used k equal to 2, or we can use k equal to 3, then it will move accordingly. All values will be present 1 to 5, and the shape of our new array, new 2D array, will change accordingly. If I write k equal to 4, then you can see shape is increasing. When I write k equal to 1, shape is decreasing. We can also use negative value for k, and syntax will be k equal to -1. What will be the output according to you? Okay, when I run this, you can see that the elements of our array B are now present lower side from the main diagonal. Similarly, when I use k equal to -5, then you can see the output will be like this. Means the elements will shifted at -5th index from the main diagonal. So that's how we can use the diagonal function to create a diagonal array and to extract the diagonal elements of an array. Hello friends, welcome to Data Science Lovers. In our last video, we learned about the diagonal function. In this video, we will learn about the transpose function. We will see the definition and syntax of transpose function. Then we will do the transpose of a 2D array, of a 1D array, and transpose. Let's start. What is transpose function? The transform function is used to convert the rows into columns and convert the columns into rows of an array, or you can say of a matrix. The simple syntax is we have to write our array dot, we have to use a letter T, means transpose, or there is an alternate way to use transpose function using numpy. We have to use numpy library dot transpose, and in the round brackets we have to pass our array variable name or array name. Okay, now first of all we will import numpy library. Import numpy as np. The library has been imported in this Jupyter Notebook. First of all, we will see transpose of a 2D array. As you all know how to create an array using numpy, the syntax will be np dot array round brackets and two square brackets because we have to create a 2D array. Now we have to pass the elements of this array 1, 2, 3, and for second row I will write 4, 5, 6. Okay. We will save this in a variable a for our reference. When I print this 2D array, you can see it will look like this. It has 2 rows and 3 columns. Okay. Now if we do the transpose of this array, then as per our syntax, our array name dot t. When I run this, you can see all the rows are now converted into columns and all the columns are converted into rows. 1, 4 was our first column. Now this becomes our first row. 1, 4. 1, 2, 3 was our first row, and after transpose 1, 2, 3 becomes our first column. So that's how simply we can use transpose function on a 2D array. Now if we want to check the shape of our original array a dot shape, then it is showing 2 rows 3 columns. But if we check the shape after the transpose, then it will show 3 rows and 2 columns. Okay. The alternative command to transpose is using numpy library np dot transpose function, and here we have to pass our array. Our array is stored in the variable a, so I can simply pass a here. When I run this, you can see this is the output of array a after transpose. This is similar to the. Now we will use the transpose function on a 1D array. First of all, we will create a 1D array, and the code will be simple. np our numpy library dot array function. Inside this array function, we have to pass the elements for our 1D array. Suppose I pass 11, 12, 13, 14, 15, 16. I am passing 6 elements here. We will save this in a variable b for our reference. So this is our 1D array with 6 elements. Now if I do transpose of this 1D array b dot t, then there is no change after the transpose. Means for 1D array there is no change using the transpose function. We can also check the shape of our original 1D array b. It is showing 6 elements, and after transpose also it will show 6 elements. Okay, so this is the property of transpose function on 1D array. There will be no change. Now we will use transpose on a 3D array. First of all, we will create a 3D array using array function from numpy library. Here I have to pass 3 square brackets because I have to create 3D array. I will pass the elements for our array 1, 2, 3. Next I can pass 4, 5, 6 and 7, 8, 9. We will save this in a variable c. When I print c, you can see this 3D array is containing of one matrix, and in this matrix there are 3 rows and 3 columns. When we perform transpose function on this array c, then it will look like this. It will become clear to you when we will check the shape of our original array c dot shape. it is showing 1 comma 3 comma 3, and when I check the shape after transpose, it is showing 3 comma 3 comma 1. Okay, now what is happening here? Earlier our C array was having one matrix, this one, and 3 rows and 3 columns. Okay, when we do the transpose of this 3D array, then after transpose, the shape is changed to 3 matrix. You can see this is our first matrix, this is our second matrix, and this is our third matrix. And each matrix having 3 rows. In first row we have only one element 1, in second row we have 4, and in third row also we have only one element, and same for the other two matrix, only one element in each row. And last is for columns. In each matrix there is only one column. This column containing 147, this is containing 258, and this is containing 369. So that's how we can perform transpose of a 3D array. So friends, this is simple. In our next video, we will talk about the unary operators from NumPy library. Okay. Hello friends, welcome to Data Science Lovers. In our last video, we learned about the transpose function. In this video, we will learn about unary operators in NumPy. Unary operators are those operators that require only one operand. As we are talking about the unary operators for NumPy, so there are functions here, and these functions can be applied row wise or column wise of a 2D or 3D array by setting an axis parameter. We use this axis parameter to consider row or columns in the NumPy arrays. Let's see some examples. First of all, we will import the NumPy library in this Jupyter Notebook. Import NumPy as np. Suppose we have a simple 1D array. np dot array, and here we will have some values. Okay, I will save this in variable a, and this is my 1D array a, which is having 4 values. Suppose we want to check the maximum value from this 1D array. So our variable name where our array is stored dot max function. When I run this, it will show the maximum value from this array. So this is a unary operator. Similarly, we can show the minimum value using min function. This is also a unary operator. It is showing the minimum value. Similarly, we can check the sum of all the values of this 1D array using the sum function like this. It will show the sum of all these 4 values. Now we will use the unary operators on a 2D array. Suppose I have a 2D array, np.array 1, 12, 55, and like this 53, 90, and 2. I will save this in variable b. This is my 2D array. When I print this, it will look like this. It has 2 rows and 3 columns. Now if I want to use the max function on this 2D array, then b.max, then it is showing the largest, or you can say maximum value from all values. Okay, it is considering the rows as well as column here. Now suppose I pass the parameter inside this max function, the axis parameter that we were talking about, axis equal to 1. When I run this, it will show the output like this. It is showing the maximum value from each row. From first row, the maximum value is 56, and from second row, the maximum value is 90. Now we can also use on axis equal to 0, b.max, and this time we will pass our parameter axis equal to 0. When I run this, it will show the maximum value from each column. From first column, maximum value is 53, from second 90, and from third column, the maximum value is 56. Similarly, we can check the minimum value from this 2D array using min function. When I run this b.min, it will show the minimum value, and it will consider both rows and 3 columns. And we can use the axis parameter in min function also. Axis equal to 1. When I write, then it will show the minimum value from each row. From first row, the output is 1, and for second row, the output is 2. Similarly, we can use x is equal to 0. Then it will show the minimum value from each column. 1, 23 and 2 are the outputs. We can also use the sum function on this 2D array b dot sum, and it will show the sum of all values of this 2D array. We can use the sum function x is y is also. B dot sum x is equal to 1. When I run this, it will show 80 and 145. Since we passed here x is equal to 1, so it will work row wise. And for the first row, it will show the sum of all three values. It is showing 80. Similarly, for second row, the sum of these three values is 145. And we can use sub function with x is equal to 0 also. It will show the sum of all three columns values. 1 plus 53, it is showing 54, and second is 113 and 58. Okay. Now we will use the unary operators on a 3D array. First of all, we will create a 3D array. C equal to np dot. This time we will use the arrange function from numpy library. Arrange 18. It will show 18 values from 0 to 17, and if we print C now, it will show the output like this. As we have to use a 3D array, I will reshape this in the form of a 3 by 3, and we will use two matrices here and 3 rows and 3 columns. Now when I print C, it will show the output like this. Now it is a 3D array. First of all, we will use the max function on this array, and it is showing 17. 17 is the maximum value in all these values, in both matrix and in all rows and all columns. When we use min function, it will show the minimum value. Minimum value is 0, as you can see. If we use max and minimum function on our axis like this, axis equal to 1. If I run this, it will show the output like this. It will show the row with maximum values from each matrix. So it is showing two rows. First row from first matrix, second row from second matrix. Similarly, we can use minimum function. This time we will use minimum function on axis 0. It will show output this. Here the comparison for the minimum value is done between the columns of these two matrices. As you can see, all three columns of first matrix are smaller as compared to the all three columns of the second matrix. So in the output it is showing this. The first column values are smaller than the first column values of second matrix. Similarly, the second column values are smaller than the second column values of second matrix, and the third column values are smaller as compared to the third column values of the second matrix. Now we can also use the sum function. C dot sum. It will show the sum of all the values from this 3D array. You can use sum on axis 1 as well as on axis 0. So that's all for this video. In our next video, we will talk about the VStack and HStack in the NumPy library. Hello friends, welcome to Data Science Lovers. In our last video, we learned about unary operators. In this video, we will learn about the VStack and HStack in NumPy library. First of all, we have the definition here. VStack or HStack is used to combine two or more arrays to form a new array. Okay. If we talk about VStack, then it is used when we have to combine the arrays vertically, while HStack is used when we have to combine the arrays horizontally. While doing this exercise, you have to keep these two images in your mind. Vertical means one above one, and horizontal means one after one. Okay. First of all, we will import the NumPy library in this Jupyter Notebook, and the syntax is import NumPy as np. Okay. Now we will do VStack and HStack in 1D array, 2D array, and at last in a 3D array. So suppose I have a simple 1D array, np.array with 5 elements in it. This is my simple 1D array. I will save this in variable a. I will create one more 1D array which also have 5 elements, and I will save this in variable b. Now I will use VStack first of all on these two arrays a and b, and the syntax will be np.vstack, the round brackets means function, and inside this function we have to pass our arrays in the form of a tuple. Tuple means the round brackets like this. Here a comma b we will pass like this. When I run this, you can see the output is like this. Here we have a 2D array with 2 rows and 5 columns. And if we see this image vertical, one above one, as we have used VStack, so we will get a output like this. Here you can see that both the arrays A and B are arranged in a vertical position, means one above one. So this is VStack. Similarly, we can use HStack also, and the syntax will be np.hstack, the function, and inside the function we have to pass our arrays in the form of tuple a comma b. When I run this, you can see the output will be like this. If you see this figure, the elements are one after one. Similarly, here the elements of first array 1, 2, 3, 4, 5 and the elements of second array 6, 7, 8, 9, 10 after our first array. Here you have to notice one thing. While we used HStack on 1D array, the dimension of our new array is same as our previous array. Okay, and while we use VStack on 1D array, the dimension of our new array has increased, and the new array has dimension of a 2D, means it is a 2D array now. So this is the difference you have to notice in VStack and HStack. Now we will use VStack and HStack on 2D array. Suppose I have a 2D array, simple 2D array I will create. This is my first 2D array. I will save this in a variable p, and this is our 2D array having 2 rows and 4 columns. One more 2D array I will create. This is my second 2D array. I will save this in a variable q for my reference, and when I print q, this is our 2D array which is also having 2 rows and 4 columns. Okay, first of all we will use VStack on these array p and q, and the syntax will be same as above. np.vstack, the function, inside function we have to use tuple p comma q. Okay, we will save the output in a variable. Suppose I use v2, vertical 2D array. When I print v2, what we see, the output is like this. From this 2 array we create a new 2D array, and array p here 1 to 8 is above our array q here. Okay, it is simple friends, you can easily understand what is happening here. Our array p is this one, and below this we have our array q. So this is VStack in 2D array. Now we will use HStack here. The syntax will be same as np.hstack, the round brackets p comma q. I will save the output in a variable h2, HStack and 2D array. When I print h2, the output will be somehow like this. Here the elements from first row of both the arrays now arranged in a single row, and elements from second row from both the arrays arranged in a new row. Here if you notice, when we use VStack, the dimension of our new array is also 2D, and also while we use HStack, the dimension of our new array is 2D. Means there is no change of dimension while we use HStack and VStack in a 2D array. Now we will see VStack and HStack in a 3D array. I will create two 3D array, simple 3D array, np dot array. This is my first 3D array. I will save this in variable x. Okay, it will look like this. I will create one more 3D array. This is my second 3D array. I will save this and it will look like this. If you want to know how to create 1D, 2D or 3D array, you can watch our previous videos of this NumPy playlist. Now we will use vstack first of all, and the syntax will be np library numpy library dot vstack, and inside the tuple we have to pass our arrays x, y. When I run this, it will look like this. It is simple to understand that our array x is above our array y. Means both the arrays x and y are arranged vertically. I will save this in a new variable v3 for my reference, and I will print v3. The output is this. If we check the shape of this v3, our new array, then it is showing 2, 3, 3. Means there are two matrices, and in each matrix there are 3 rows and 3 columns. Okay, now we will use hstack, and the syntax will be np dot hstack, and inside the tuple we will pass our arrays x, y. I will save this in a variable h3 for my reference, and I will run this, and when I print h3 here, it will look like this. When we check the shape of this h3 dot shape, the shape is one matrix, 6 rows and 3 columns. Okay, so it means while we combine two 3D arrays using hstack, the output will be like this. It will form a single matrix from our two matrices from different arrays, and all the rows will combine one after other, and so total we have 6 rows, 3 plus 3, 6 rows, and we have 3 columns here as per our original arrays x and y. So that's how we can use vstack and hstack in 1D array, 2D array and 3D array. And friends, it is a useful important topic. In our next video, we will learn about the array indexing, means how we do indexing in our arrays. Hello friends, welcome to Data Science Lovers. In our last video, we learned about vstack and hstack. In this video, we will learn about array indexing in NumPy. First of all, what is indexing? Indexing is used to obtain the particular element or row or column from the NumPy arrays. We can obtain more than one element or row or column in the NumPy array, or you can say NumPy arrays. Here we pass the index of the element to access it. The index starts from 0, not from 1, and the last point you have to notice is it returns element till our stop index -1. Okay, these 4 points will be cleared when we will do some example here. First of all, we will import the NumPy library in this Jupyter Notebook, and as you know, the syntax is import NumPy as np. Running this, the library has been successfully imported. Now we will talk about indexing in 1D array, 2D array, and at last in 3D array. Before moving ahead, we should talk about indexes. Suppose I have a simple 1D array. This is my 1D array which is containing 5 elements in this. Now as per our third point, the index starts from 0. So this first element 1 is present at our index number 0. This second element at index number 1, and so on. This fifth element 58 is present at our index number 4. So for these 5 elements in this 1D array, we have indexes 0 to 4. These are indexes of this 1D array. Let's do some exercise. We have a simple 1D array. In this array, we have 5 elements from index 0 to 4. When I want to obtain this element 1, which is present at my index 0, I can simply write my array variable name a, this square brackets, and my index number 0. When we have to obtain only one element from the array, then the start index becomes automatically equal to our stop index. So we have to pass only one index value here. If we run this, it will give the output 1, means at index number 0, 1 is present. If we check at index number 3, then it is showing 46. As we can see here at index number 3, we have 46. When I write nothing as my start index colon and nothing as my stop index, then it will show all the elements present in the array like this. Okay. To get all the elements of the array, we have one more way. We can put start index as 0, the colon, and we can leave blank as our stop index. So our elements will start from index number 0 and it will show the elements till the end, and the output will be our all elements of the array. Suppose I write start index as 2 and colon and nothing at our stop index, then in the output it will give the elements from the second index 0, 1, 2. It will give the elements from 34, 46 and 58. Okay, when I run this, it will give the output 34, 46 and 58. Now in case if we don't pass the start index and we pass only the stop index, here the start index is blank and we pass stop index as 1. When I pass 1 here and run this, it will give the output 1. 1 means the element which is present at our 0th index. Here if we see our point number 4, it returns element till stop index minus 1. Here we have passed stop index as 1, then it will return the elements till our 0th index, because 1 minus 1, 1 minus 1, 0 equal to 0. So it will return the elements till 0th index only, and at 0th index we have what? We have 1. Okay, so it is returning 1 here. Now if I pass nothing at start index and when I pass stop index as 5, so as per your understanding, what will be the output? So if we see here, the output will be from index number 0 till index number 4, because as per our fourth point we have in an index 5 and one index less here minus 1, then it will show the output till index number 4 only. If we run this, this is the output. If I pass stop index as 4, then it will return the elements till index number 3 only, till 46. 46 is present at my index number 3. I am printing our array again here for our reference. Suppose I want to extract this element 22 from this array, then I can use slicing here. I have to pass my start index as 1, 22 is present at my first index, the colon, and we have to pass stop index 1 greater. Okay, so we have to pass index number 2 here. When I run this, it will give the output 22. Similarly, when I want the output 34 and 46, so we have to start from this 0, 1, 2, from second index colon, this stop index should be 1 greater, so 0, 1, 2, 3. We want elements till third index, so we have to pass 4 here, then it will show element till third index only. So this is the indexing in 1D array. You have to remember these points here. Let's move to indexing in a 2D array. Suppose we have a simple 2D array P. In our first row we have 4 elements 11, 12, 13, 14, and in our second row we have also 4 elements 15, 16, 17, 18. Here this first row is present at our index number 0 and this second row is present at our index number 1. Okay, and this column is present at our index number 0. This column is present at index number 1, index number 2 and index number 3. Okay, This is the format for our reference about indexing in 2D array. Here first we have to give the row indexing and then we have to give the column indexing. We will do some example here. Suppose we have a simple 2D array. This array B is our simple 2D array having 2 rows and 4 columns. Here, as I explained you, this first row is our index number 0 and the second row is at index number 1. Similarly, this is our column index number 0, column index 1, 2 and 3. Okay. Now, when I want to extract this row first, our array name, and in the square brackets I can simply pass 0 here and the output will be 11, 12, 13, 14, means our first row which is present at our at our 0th index. If I give index here 1, then it will give us the second row because it is present at our first index of this 2D array. Now when I give B start index as nothing, colon stop index as nothing, then it will show all the elements of this 2D array. If I want to extract this element 12 from this array, then what can I do? Our array variable name, the square brackets, as per our format, first we have to give the row indexing. This element 12 is present at our 0th index of the row, so I can simply pass 0 here, comma, we have to give the column indexing, and this is our column number, column index number 1, so we have to extract from here. I have to pass 1, and here in column indexing I have to give the end index. I will pass 2 here because it will give the output till only first index. Okay, one index less than our stop index. When I run this, it will give the output 12. Suppose I want to get the output 17 here, then you can try this. B square brackets, our row index, this is present in our index number 1 of the row, comma, our column index, and it is present at our 0, 1, 2. Okay, second index, and I will pass here the end index as 3. It will give the output as 17. Here we can also do some boolean indexing. Suppose we want to extract all the elements where the value is greater than 14. So B, and inside this square brackets we have to give the condition. From B we have to extract all the elements that are greater than 14. When I run this, it will give only those elements which are greater than 14. Similarly, we can extract the elements that are less than, we can say 16. Okay, it will give the output like this, 11 to 15. So that's how we can do indexing in our 2D array based on row indexing and column indexing. Now we will do indexing in the 3D array. Suppose we have a 3D array C. In this 3D array, we have two matrix. This is our first matrix, which is present at index number 0, and this is our second matrix, which is present at our index number 1. And in each matrix, there are 3 rows and 3 columns. This row is present at index number 0 of this matrix. This is present at index number 1, and it is present at index number 2. Similarly, this column is present at index number 0 of this second matrix, at index number 1, index number 2 of this second matrix. This is the format for our reference about indexing in 3D array. First, we have to pass the matrix indexing, then row indexing, and then column indexing. Suppose we have a simple 3D array C. This is 3D array C, which is having two matrices, and in each matrix there are 3 rows and 3 columns. Now when I use index 0 here, as you all know, it will show matrix first here like this, and when I use index 1 here on this 3D array, then it will show the second matrix because it is present at our first index. And as you all know, when I pass start index nothing and also stop index nothing, if I pass only columns, then it will show all the elements present in this 3D array. Okay. Now, if I want to extract these elements 14, 15, 16, 17, 18, 19. Okay, I want to extract these three elements. So, how can I do? As per our format, first of all, we have to pass the matrix indexing. And our 3D array variable C, the square brackets, these elements 14 to 19 are present in our matrix first, which is present at index 0. So I will pass index here 0, comma, then we have to pass row indexing. This row 14, 15, 16, this row number second is present at our index number first. So I will pass here row index as 1, start index 1, and stop index I will pass 3 here because I want these two rows. So as the last row is present at index number 2, so I have to pass one index greater than our actual index. So I will pass 3 here. Then we have to pass the columns indexing. As we'll need all three columns, so I can simply pass a colon here. It will consider all the columns. When I run this, it will give our output 14, 15, 16, 17, 18, 19. When you try this example by yourself, you can easily understand this. So now suppose I want these elements 21, 22, 24, 25 and 27, 28. So I am doing here, no, I am doing here only our array 3C. Here first of all we have to pass our matrix index. These elements are present in our second matrix, which is present at our index number 1. This is our indexing for matrix, comma, we have to pass the indexes for rows. As we need all three rows of this matrix which are present at index 0, index 1 and index 2. So I can simply pass colon here because it will consider all the rows present in the matrix. And as I want only the last two columns, so I will pass start index as 1 and colon my stop index will be 3 here in this case because I want the elements of the column till index number 2. So I will pass 3 here. When I run this, it will give the output as per our requirement 21, 22, 24 and 25, 27, 28. Okay. Now in case I want to extract only this element 24. Okay. What we can do? For this, I can simply write one interesting indexing 1, 1, 1. Okay, when I run this, it will extract the element 24. Why? Because it is considering first the matrix which is present at index number 1. At index number 1, we have this matrix. Then it will consider the row indexing, the one we have passed here. Then it will consider this row which is present at our index number 1. And at last it will consider the column indexing. We have also passed 1 here, and in this matrix this is our column which is present at index number 1, and in this column it will select 24 and it is showing 24 in the output. So this is indexing in our 3D array. Okay. So that's all for this video. More advanced features of indexing will be covered in our another playlist of the course, which is Advanced Data Analysis with Python. And in next video, we will cover our last topic of this playlist, any and all functions in NumPy library. Hello friends, welcome to Data Science Lovers. In our last video, we learned about the array indexing. In this video, we will learn about any and all function in NumPy. The any and all functions are built-in functions in the NumPy library, and these functions works on the comparison basis, means these are used to compare the values. If we talk about any function, the any function returns true if any element from our sequence or list satisfy the given condition. While if we talk about all function, it returns true if all the elements of our sequence satisfy the given condition. It will be more clear when we will do some examples here. This is the syntax of any function. We have to use NumPy library np.any and then we have to put our condition. And this is the syntax of all function. We have to use our numpy library dot all function, and again we have to put our condition that we want to check. The any function uses the logical or operator, while the all function uses the logical and operator. Okay, we will see some example now to understand it. First of all, we will import the numpy library in this Jupyter notebook. This is syntax: import numpy as np. From numpy library, I am importing the random module to create a random array. From this random module, I am creating a random array which will contain 15 values, and these values will be from 10 to 1000. Okay. When I run this, the command has been executed, and when we print x, our random array, this is the output. Here are 15 values between 10 to 1000, and all these values are random. If you want to learn about this random module or random function, you can watch our previous video of this playlist. Now let's see how the any function works. Suppose from this array x, I want to check if any value is equal to 500. So I can do this with the help of any function. Our syntax will be np dot any function, and here we have to put our condition. For the condition, I will write x equal to 500. It will check if any of the element in this array x is equal to 500. If the condition is satisfied, it will return true, otherwise it will return false. When I run this, you can see it is returning false, means none of the elements in this array is equal to 500. If you want to check one more condition, np.array, this time I want to check if any element from this array is less than 100. So I can simply write x less than 100. When I run this, it is again showing false because none of the element is less than 100. When I write if any element is less than 1000, x less than 1000, then obviously it will show true because all the elements here are less than 1000. And if I write if any element is greater than 1000, then it will show false again because none of the element is greater than 1000 in this array x. So that's how we can use the any function for the comparison in numpy and get the output in the form of true and false. Now we will see what is all function. Suppose I have this array again x, and as per the syntax of using all function, we have np.all and then condition. np.all, and here we have to write our condition. Suppose I want to check if all the elements in this array are equal to 500 or not. So I can simply write this x equal to 500. Obviously it will show the false because it will check each element one by one for the given condition, and none of the elements is equal to 500 here, so it is showing false. Now suppose I will check one more condition, np.all, and this time I want to check if all the elements are less than 1000, x less than 1000, then it will show true because all the elements are less than 1000. But if we check if x less than 500, then it will show false because some elements are less than 500 but some elements are greater than 500. So it will show false because all the elements are not less than 500. If we see np.all, and if we check all elements are greater than 300, then what will be the output according to you? It will check each element one by one of this array, and it will verify this condition if the elements is greater than 300. If all the elements are greater than 300, then only it will show true. Otherwise, if a single element is less than 300 or equal to 300, it will show false. When I run this, it is showing false because some elements are greater than 300 while some elements are less than 300. So it is showing false here. You can do some more exercises with these any and all function. It is very simple and easy to understand. So that's all friends for this video.